Okay, today is 10.2, and it's our third day of trig, if you conclude that first day, which was super easy. So anyway, we are into the string problem now. So in the classroom, you can't see this on the board, but in the classroom here, we have a setup where we've got Spider-Man and Spider-Man's clone. Did you guys read, or just see on the internet the story about the little monkeys that have been cloned? It was a really cute little video of these little baby monkeys playing with each other. They have cloned monkeys. You've heard before that they had cloned sheep, right? Dolly the sheep, that was the very first big cloned thing. If you hadn't heard that, that was a while ago. Now they've moved up to monkeys. And they're letting us know about that. What does that mean to you? There's probably stuff cloned that we don't know about because they keep that top secret. So anyway, I'm guessing already somebody has cloned humans. I'm just throwing that out there. I don't know it to be true, but I'm guessing that it's already happened in some lab and they're not telling us about it. Anyway, so I've got my Spider-Man and Spider-Man's clone, and this I think is kind of cool. If I have a triangle here, and I got my one Spider-Man down here, and I got my other Spider-Man up here. If I have a right triangle and I have one side and one angle, then life is really easy. And I want to show you just a review of that. Let's say Spider-Man's able to somehow judge how long his web is, and it's 30 feet long right here. And he knows the angle he's using is about 30 degrees. He should be really easily able to figure out this distance. We'll call it the height of the building that he's in. He's got a 30-foot long web, and he's got a 30-degree angle right there. Would you please figure out H? One side, one angle, piece of cake. And pause while you try that. So I totally respect two different approaches, one of which would be to say sine, cosine, or tangent of 30. And which one was it, by the way? You should be able to do this by now. Sine is opposite and hypotenuse. Sine 30 would be h over 30. Okay, and now I can get that solved, getting h alone, by timesing by 30 on both sides. And I have 30 times sine 30. But we know these side relationships within a triangle, which would have done this a lot faster. Do you guys know if this is 30, 60, 90? What's that relationship between this 30 and this h? 2 to 1. And therefore, what's h? 15. Boom, done. See how fast that is? So if you know those relationships in 30, 60, 90, you don't have to grab your calculator. But if you had, guess what? Since we know that the answer is 15, what does sine 30 have to be? 1/2. I want you to think about that for a second, because I know from knowing this relationship that has to be half as big as 30, so it has to be 15. Then sine 30 must be a half. Here's another thing to say. If you really know your 30, 60, 90, and I say sine of 30, you can go like this. I know this one. It's the 1, 2 square root of 3 triangle. So what's the sine of 30? You look at the 30 and you go, sine is opposite over hypotenuse. It's 1/2. See what I mean? You can calculate these in your head from knowing those classic right triangles. To see if you really understood what I just said, I'll circle all three sides now just to keep some symmetry there. Would you please figure out what is the cosine of 30 without your calculator? Just use that. See what I'm saying? You don't need a calculator. You can just look at your classic 30, 60, 90. Say cosine is adjacent over hypotenuse. Did you have root 3 over 2? Raise your hand if you had that. Okay, good. What else could we figure out? Well, a whole bunch of things, because you also have this one memorized. Which triangle is that again? 45, 45, 90. And what's the sine of 45 then? I might be thinking, wait a minute, which 45? If you do them both, they come out the same. Sine of 45. So I'm going to use that one. Sine is opposite over hypotenuse. 1 over root 2. Raise your hand if you had 1 over root 2. Okay, good. All right. So that's why knowing those triangles is super important. It's because if you're on a test and it gives you like sine of 60, you got to be able to figure it out without a calculator. Please try that right now. Figure out sine of 60 without your calculator. Draw it. Don't just try to think it. Draw it. We're visual people. That's why you remember movie clips so much better than you just remember some math teacher talking. So you can picture something, you can remember it. I make the 30, 60, 90 that way, but you can make it any way you want, as long as you label it and know which one's which. I'm going to say that's 30. 1, 2, root 3. And I use the 60 this time. Sine of 60, opposite, hypotenuse, root 3 over 2. Raise your hand if you had that one right. Okay, good. Okay, so there's kind of a review to catch us up to where we are. Now, the string problem. What's different about the string problem is this. You aren't given one side and one angle, because you only have like part of one side, and that's this right here. And so here's your scenario. Spider-Man's standing here, and he's got a angle. He knows that he's at a 30 degree angle right here. And he takes 10 paces forward, in order to say 10 feet forward. And he takes another reading of his angle. Do you get the angle to be a lot bigger? Because he's kind of walked towards this guy stuck to the roof. So then this is going to be a 60 degree angle. And if I know that little piece of a side, and I know the other's 30 and 60, I can get the answer. But here's the thing you got to recognize. You have a missing distance right here that we need a name for. Okay? Should we call it x? No, we already had something else called x. Let's call it y. If we knew y, then we'd know everything, because we'd have a whole side. We'd have 10 plus that. We'd know a side. We'd know an angle. We could find everything. Okay? So really your goal is to figure out y right now. Now, within that triangle, we still don't have enough info. I know some of you might be thinking, well, I'll just take this triangle here then and figure it out. No, you still only have one angle there, so that's not going to work. So this is a critical piece. If you have two variables, then you need two equations to solve it. Back to the day when you used to have things like this. You could solve these two equations. It's called a system of equations. And then you could figure out what x and y had to be. Why? Because you had two variables and you had to have two equations to solve it. Do you get if I just have one equation with two variables, then I can't solve that. I don't know what x and y have to be because I don't have enough info. What do you think? If I had three variables, how many equations do you think I might need? 3. If you have three separate equations and you have three variables, you can solve that system of three variables. And this can get even more insane if you're Elon Musk and you're trying to run Tesla and you've got all these inputs and outputs for your factories and stuff. You might have 17 different variables. So he would need 17 different equations that he could start solving, and he could solve that system and figure out what every variable had to be. But if you have two variables like us right now, which are h and y, if we have h and y as our two variables, we just need two equations. Would everybody try to generate two trig equations that involve h and y? They don't have to both have both parts. In other words, they don't have, both equations don't have to have h and y in them. That's awesome if you can make that happen. depending on the problem. Sometimes you do have to have both equations have both variables in them. All right, how many of you saw that together could be called 10 plus y? Anybody notice that? Raise your hand if you actually have that as part of your master plan. You're right, that's smart. Then I've got one side, and I've got an angle. And then I use that to write an equation. For that 30-degree angle, what sides do I have? I have its opposite and I have its adjacent. For the 30-degree one, that's the big triangle, I have its opposite and its adjacent. That's tangent. Tangent of 30 is TOA, opposite over adjacent. I can now fill in what opposite is. Opposite is h over adjacent is 10 plus y. There's an equation. Now, tangent of 30, could I use a calculator to do that? Absolutely. Or, do you get that's also one of the classics, 30, 60, 90 triangle, and therefore you wouldn't have to have a calculator to do it. All right, but since you have calculators, go ahead and use tangent of 30 that way, and then you'll have a nice simple equation that doesn't even have trig in it anymore. Now we need another equation. The other equation is much simpler. It's much cleaner anyway. I'll draw that one with my fancy dotted green lines here. That one, and that one. I don't know if I hope that stands out bright enough to you, that bright green triangle. And for that bright green triangle, at the 60-degree angle, and I have opposite and adjacent again, so tangent of 60 is equal to TOA, opposite, which is h, over adjacent, which is y. Cool. And again, tangent of 60. You could do it off to the side of your paper with one of your classics, 30, 60, 90 triangle. 1, 2, root 3. And I could figure out tangent of 60 that way. Or you could use a calculator. I don't care which way you do it. Here's my 60. Tangent of it, root 3 over 1. And some of you probably found the decimal for it with your calculator and figure out tangent of 60 is some decimal, which happens to be root 3. All right, I'm going to take a moment and use my calculator and figure out tangent 30 and tangent 60. Okay, so my tangent of 30, please correct me if you think I'm screwing up something, because, like, what if I had been in radians? And if you get something different, maybe you're in radians. It should be in degrees. Tangent 30 is that, and tangent 60 is 1.73, which must be what square root of 3 is. Now, that is a typical test question. We're not going to give you a simple little triangle and give you one side and one angle. That's too easy. That's what you would have gotten in higher algebra. You're an honors pre-calc. So this is the kind of setup that you'd have. 2 variables, you have to write 2 equations. So let me clean this one up and I'll solve it here. 0.577 equals h over 10 plus y. And the other one here was 1.73 is equal to h over y. Now, I need to solve for h on one of these two at least. So I'm going to solve this one for h because it's going to be really easy. I'm going to times it by y. H is that. Well, if I solve this one for h, that'd be pretty smart. I'm going to multiply both sides by 10 plus y. By now, you should have it ingrained in you that if you see a fraction, you multiply by that denominator to get rid of that fraction. And here's h for the one equation, and here's h for the other equation, and then you can set them equal to each other. Since h is this and h is that, then 10 plus y times 0.577 must be y times 1.73, because h is equal to h, so that has to equal that. Now, what's good about this? It only has y's in it. and I have to trust that you can solve it from there. For me, I'd probably multiply it all the way out. This 0.57 times the 10, 0.577 times the y. Then I would get rid of the smaller y and solve it down. I'm going to pause for a second while you do that. If you got lost somewhere earlier, write this equation down from here and make sure you can solve it from here. Okay, I got this line. Now I'm going to subtract the smaller y. I subtracted the smaller y and I got that. Now I'm going to divide both sides by 1.153. If your rounding is slightly different than mine, I'm not worried about it. I hope you don't get worried about it either. Now at the end, I kind of cheated because my calculator said 5.004. But do you get that that tells me 0.004 that this answer is probably 5? Why was I off at the end? Because I rounded. But at the end, I was 5.004, so I could tell that the answer must have been 5. Okay. So that's a tough one. That's honors pre-calc for you. That's probably the toughest question you'd see on a test. So don't stress like everything on the test is going to be like that. No, there'll be easy stuff too, but that's a typical thing. All right, now let's get into some more stuff that you get to learn about pre-calc that you didn't know before. One of them is bearings versus true bearings. This doesn't maybe even seem like pre-calc, but it is. It's going to be involved in word problems, and it involves using sine, cosine, and tangent and right triangles. But here's a typical scenario that we'd use it on. Like, this guy is out in the middle of the ocean, okay? And he's told to go at a bearing of 73 degrees. Do you have any clue what that even means? You will in a minute, okay? And so let's say a bearing of 73 degrees is like that, okay? Well, then he stops here and is told, okay, from your position now to try to get to this island that you're trying to get to, you better take a bearing of 94 degrees. Okay, and let's say that that's that direction. And then you stop. And then you say, okay, you know what? We're going to punt on this thing and not even try to go to the island. We're going to go back where you started from. And the question would be, what bearing do you need to set to get back home? All right. So I'll show you how to use like a little compass rose thing here, here, and here to figure out what these mean. All right, so I'm going to give you the cleanest one possible, and that's you're out in the middle of the ocean, you're right here, and they tell you to take a bearing of 0. Anybody take a guess at what that means? Yes. Straight, what? Up, which means north, yes. A bearing of 0 degrees is up here, and it's also the same as north. So then take a wild guess what a bearing of 90 degrees would be. All right, so at 90 degrees, it must be this way. Is that north, south, east, or west? Well, it's definitely not north. Which way is it? East. Okay, so that would be bearing of 90, also known as east. And I think you got the pattern here, so if I say this, what do you think that's going to be? Say it if you know it. Nobody knows it, seriously? Come on, don't chicken out. 180 would be what? South. And how about this way? 270, and that's east. Now, sorry. It's okay. I just said what I heard, and it's easy to make that mistake. All right, so now, there we go. So I think you get the idea. If I say to go 370 degrees, what? 360 would have been 0, so 370, it's kind of weird. Nobody would ever say that if you're a ship captain. 370, what are you talking about? Okay, but could you go 359? Yeah, that's more like kind of 1 degree back this way. So your answer is basically saying go almost north, but a teeny tiny bit west of north. All right, so now, how do we make it more complicated? What would 50 degrees north of east mean? Pause for a second. Okay, 50 degrees north of east. Well, here's east. 50 degrees north of that would be like that. What would it have been in true bearing? Just a simple number. If this is 50, you can use logic to figure out, well, that must be what? 40, so therefore that's the same as 40 degrees true. Does that make sense to you? All right. What if I said 20 degrees west of south? I want you to draw one of these compass roses and try to figure out where that is, and then what would that be in true bearings? Try to figure out where 20 degrees west of south would be. Hint, start at south. Draw it. Is it like here? Figure out what direction you're telling that guy to go. It's not there. Draw it. Don't just sit there. Actually draw it. I want you to compare it now with the kid next to you and see if you and they think the same thing. Remember, rows 1 and 2 are the ones that compare. Rows 3 and 4 compare across. Rows 5 and 6 compare across. Well, here's south, and here's west. So 20 degrees west of south would mean this one. Not this one, because that one's gone. And if that's 20, what would the true bearing have been? 180 would have been to here, so a little bit more. That's the same as 200 degrees true. You with me? Okay, now I want you to try one of these little path kind of problems. We'll start with a simple one. You're out in the middle of the ocean, put a dot. And you get radio directions that says, all right, I want you to head on a bearing of 30 degrees. If I just say that, that's a true bearing. Head at a bearing of 30 degrees. Hint, I recommend that you put in dotted lines in a little plus. Dotted lines implies they're not really there. It's not really your course, but it helps you to keep things lined up. Really, you really want these because they're going to make little right triangles for you. All right, so if this is 30 degrees true, then that was 30. And do you get all of a sudden, I have another angle set up here, and I know every single angle that's in here because I know that one angle's 30. All right, let's see if you can get what I mean in a minute. So let's say we travel for 1 mile that way. That means that's 1. And now make another dot. You're now at a new position in the ocean. This is called a compass rose, north, south, east, west. And then from there they say, now from where you are right now, take a new bearing. And I want you to go let me think this through. How about this? You guys can do this. What bearing should I take so that I make this into a right triangle? You know, when I make this, like what bearing would that have to be? Figure out what bearing that would have to be to make this a right triangle here. Okay, I'm going to pause for a second while you figure out what bearing that would be. It's really this number you're trying to figure out. It's clearly more than 90, right? I'm going to pause for a second while I figure that number out. Okay, so here's the way you could be thinking this through. This may have been a long time for you since you did this, but do you remember a thing called interior and exterior angles and alternate interiors and all that kind of stuff? Is this ringing a bell? Yes, geometry flashback. Awesome. That's what I'm hoping you're getting. Then that is the same as that. It's a big deal that you can catch that one. That one comes up on the ACTs all the time. They see if people remember that alternate interiors are a thing. If How do we know that those two pink lines are actually parallel to each other? Because they're compass roses and they're north-souths. So they have to be the same. They have to be parallel. All right? So then if this is 30, then that's 30. If that's 30, then how much does this need to be to make it a 90-degree angle like we wanted? That has to be 60. If that has to be 60, then how much does this have to be to make that part be 60? Well, total's 180, so 120. The red line should have been a bearing of 120. How many of you guys were able to figure that out? A lot of you. Nice work. And there's a lot of ways to do it. Yeah, you do not have to do it that way. As long as you got 120, there's a lot of ways to figure that one out. Okay, so now let's say that the person went for 3 miles in that direction. Do you get how we could say, all right, now tell me what the bearing home is? Oh dear. All right, what do you think we need down here besides a dot? Another compass rose. Now, if I'm going to make another pink line, you know why? So I'm going to set up alternate interiors again, or alternate exteriors, or all kinds of different possibilities. And then I'll say, if this angle right here was 60, can you tell that this angle right here needs to be 60? And if that angle right there is 60, then what's this angle right here? That must be 30. And now I'm going to have to get home. That would be this line right here, bringing me back to my original spot. Do you get that my bearing has to be more than 270? It's like 280 or so to get back home. All right, I need to stop taking this much time on this question. So at least you've got the idea of the setup of these. Key moments. When you start, make a compass rose. Oh, make it with dotted lines though. I'd like you to do a simple one. I'd like everybody to start a new one and go at a bearing of 20 for 3 miles. And then, really simple one. Now you want to go back home. What's the bearing to get back home? Don't say it. Figure it out. Draw a little picture. I'm going to pause while you do that. Okay, so we're back. And you should have gone 20 degrees, which is like that. Makes that 20. You go up to your compass rose up here, and you say to yourself, what do I know about these angles? If that's 20, that must be 20. If that's 20, then what's the bearing back home? That's this thing, to get back home again. If that one was 20 right here, it's 180 plus 20 is 200. Raise your hand if you had 200. All right, good. Then you got the basics. This is really going to come into play tomorrow. But I know it's so difficult that I wanted to spend a lot of today talking about that one. All right? So now you kind of got a great preview of tomorrow's lesson. So what is today's like? Today is just word problems that end up being right triangles with one side and one angle. See what I'm saying? We already learned how to do this, but now it's like a word problem that sets up a right triangle. All right, so let's find one. Here's a part of your homework. I want to get to your homework right now. And it's, you flip through. I'm sorry that there's so many slides, but there we go. Nope, that's day 2. Sorry. Pausing to. Here's the one. Required day 1. All right. The angle of depression from the top of a building 60 meters high to a swing in the local playground is 58. All right, so they're doing this. They're saying the angle going down to that swing right there, that angle of depression is 58. Now, which angle is 58 though? All right, here's how you define an angle of depression. From straight, like if you were standing on the top of the building and looking straight across, the angle of depression is this angle. It's the angle at which you tilted your head down. So that is 58. It's very common for kids to think it's the other one. When I say the other one, I mean like this angle here, that's not 58. All right. That is the start of your right triangle. Now, of course, you can make the rest of the right triangle by just drawing that. Do you get how they just gave you an angle? Now, they got to give us a side. And if they didn't give us a side, we couldn't do it. So they must have given us a side. So which one is it? The blue, the black, or the red one that's 60? The building is 60 meters high. Is that the red one, the black one, or the blue one? Blue one. Blue one is 60. Look at how they gave me an angle, they gave me a side, and you can just keep looking at the problem until you figure out how they did it. They had to have given you one angle and one side in a right triangle. That's how they're always going to work. It's just a matter of like trying to figure out which one of these is the angle that they gave me. Again, the classic mistake here would be to think that the 58-degree angle was here. It's not. The angle of depression is from looking straight across, from looking horizontal down like this way. That's the angle of depression. Okay, now that that's set up, that'll be an easy one. Well, let's do a few more. I want you to do this one. Now this one, here's the lamp post. Okay, this is the lamp post is leaning away from the sun. Okay, now we have to, here's your drawing from the sun. Here's where the sun would be. I want you to put the sun on here. And when it says 6 degrees from vertical, that's what vertical would be. So if it's really 6 degrees from vertical, do you get there saying that angle right there is 6 degrees? Because vertical would have been straight up and down. If it's 6 degrees off of vertical, then here's vertical, here's 6 degrees off of vertical. That's 6 degrees right there. They must have given you one side and one angle. Just keep coming back to that. If there isn't an angle, you can't do it. And now there must be a side too. One of these sides must be known. Otherwise, you can't do it. But once you got a side and an angle, you can do it. Again, this is a very typical type of question that you can be asked. Because it's not that easy to figure out. Once you got it, it's just a triangle with a side and an angle. It's all about interpreting it. All right, so that one's assigned. And last one is that one is assigned. That's all I'm assigning you for tonight. I expect you to have them done and checked, the answer key. Now, I'm not going to have time to gather the scores from today, but I will get them tomorrow or the next day. You just need to keep those scores in your memory bank of what you got this time. If you didn't get it done this time, it could be one of your ones that gets thrown out at the end. Remember, you can have a few thrown out on the last day. I'll drop the lowest score on a few of your assignments. All right, that's all I got for you.